Welcome to the DataPower MQ integration deep dive. I'm Robin Wiley and I'm going to be presenting this to you today. I'm a senior instructor specializing in IBM messaging products, which includes MQ, DataPower and Integration Bus. I am certified for each of these products and I have over 40 years industry experience, primarily working on network integration projects. Everything from accounting systems to satellite ground support systems and just about everything in between. I have over 20 years experience with MQ and 10 with DataPower, mainly doing training and consulting, including technical architecture, designs, project management, installation, troubleshooting and all that sort of stuff. I have over 35 years experience as a corporate trainer and adult educator, getting consistently high scores on my feedback, usually over 4.8 out of 5, and many glowing testimonials which are available upon request. I also like to make my classes very interesting because as a member of the Academy of Magical Arts, I'm also a professional magician, so I like to bring a little bit of magic into my classes and show a few tricks in between lectures to keep my attendees amused. So my classes are usually quite interesting in that respect. So the focus for this class is going to be primarily looking at MQ version 8 integrating with DataPower firmware version 7.5. The topics we're going to be covering specifically include the Queue Manager object and how to define it, the intricacies of the MQ frontside handler, the MQ URL that's used on the back end of a multi-protocol gateway, how to handle message headers that are embedded inside of MQ, how to handle message errors that occur, and also transaction management very specifically. We'll be touching a little bit on JMS headers, but not too much in this particular class. There's a lot more that can be done, but this is just meant to be a 1-hour introduction at this point only. So let's look first at the Queue Manager object. Now the Queue Manager object definition, if you look at the screenshot shown here, the title is a little misleading because you notice it says Configure MQ Queue Manager, and the implication is that what we're doing is configuring an actual queue manager in DataPower, but of course there is no actual queue manager on board DataPower. This leads to a lot of confusion in a lot of people's minds because they mistakenly believe that DataPower actually hosts a queue manager in its own right and therefore can be configured with its own queues and channels and so on. This is not the case. It should have really been called a Queue Manager connection object because what it's doing is defining the connection to a queue manager that resides elsewhere. So let's look at the parameters in turn. Hostname parameter is the familiar host name that is used in typical MQ terminology, consisting of the address and the port. But notice that the address and the port can be separated by a colon, which is the more traditional TCP/IP notation, or it can be set up with the port in parentheses, which is the more traditional MQ notation. Either method is acceptable. DataPower will automatically send the correct con name clause to the queue manager according to the way MQ is expecting it. Notice also the default port, if you leave it off, is 1414 in all cases. And you can also use IPv6 notation as well as DNS resolution notation using a host name if you prefer. Now one little tip that I have here is that the name of the Queue Manager connection object can be any typical DataPower naming standard technique, i.e. 64 characters, A through Z, 0 through 9, upper and lower case, and a few special characters such as underscores. But I generally recommend that you stick with the actual Queue Manager name as it is called in the MQ environment and make that the name of your Queue Manager connection object. I find that leads to less confusion, but that's just a recommendation. You may have other standards that suit you better. Continuing on with the screenshot, if we go down a little further on the screenshot, we have a few other fields and parameters, and I want to pay particular attention to the last one on this screen, the units of work parameter. I'm going to be covering that in much more detail as we go forward. But let's look at some of the others here first of all. The channel name. The server connection channel name is filled into this field. It's got to be exactly as defined on the queue manager itself. That is 20 characters, A through Z, uppercase, lowercase, 0 through 9, also period, /, %, and underscore, the usual standard MQ character set that you can use. And it's got to be exactly spelled correctly. It is case sensitive. The channel heartbeat field needs a bit of explanation. This is an approximate time between heartbeat flows on the channel. If you set it to 0, then no heartbeat flow is exchanged between the DataPower box and the host queue manager, which may not be a bad thing depending upon the network congestion that you currently have. But the other thing that's important to note is that this does not explicitly set the heartbeat on the channel. It simply offers a negotiated value which the channel definition itself could override, because what happens in reality is that whichever is the greater of the two is used as the heartbeat interval. Next we have the cache timeout interval. How long will the DataPower box keep alive a dynamic connection in the connection cache? It must be greater than the negotiated heartbeat interval, but less than the queue manager keep alive interval that's defined on the host. Username is the next field. This is the standard 12-character username that is supplied by the client, in this case the DataPower box, to the host, i.e. the queue manager, that is usual with older versions of MQ client. This is provided as backward compatibility support because, as you'll see a little later, DataPower also supports the more modern MQCSP technique for passing a more secure client connection. But this is still available should you choose to use it. Alternate user ID. This allows you to turn on the ability to make use of the MQ object descriptor alternate user ID field. If you check the radio button off, it means that the message descriptor's user ID is used instead for queue authorization. If you turn it on, then it is necessary for you to set up some kind of code in your rule to enable the use of the object descriptor alternate user ID. So there is some coding required to make that happen. XML manager. If you decide to invoke an XML manager as part of the rule that's processing the messages coming from MQ, you can nominate one here. This is only relevant if the payload of the MQ messages is in fact XML content or SOAP content. Otherwise, it's not really necessary. Maximum message size is pretty obvious. It is the maximum size of messages that can be handled in the DataPower box by this particular queue manager object. Units of work, as I said before, this is probably the most important parameter in the sense that it controls sync point. It has two values, 0 or 1, and notice it only affects the front side handlers. It does not affect the back end. The back end has its own set of parameters. And you might ask, why is this the case? Why is it only affecting the front side? The reason is that from the MQ perspective, DataPower is seen as a single entity, a single application. And so even if you have two or more front side handlers, they are seen as simply the same application connecting to the queue manager and opening queues for different purposes, but still coming from the same physical single application. So from the perspective of MQ, any sync point handling between DataPower and MQ is considered to be the same unit of work. So that's why we have this parameter set within the queue manager connection object itself. As you'll see a little later, however, there are ways to override that, which I'll show you as well. But basically, setting this value to a value of 0 means that it turns off sync point control, which means that there is no message integrity. As soon as an MQ get is done by the front side handler, it's an immediate irrevocable delete of the message from the queue, and the message is then under the control of DataPower, and no rollback or recovery is possible. It is then DataPower's responsibility to protect that message from that point on. If you set the units of work to 1, however, it turns on automatic sync point control, which means that the front side handler doing an MQ get from the queue has an implied MQGMO sync point turned on, which means that the message is not deleted from the queue at this point, but is held for pending delete, and only when the DataPower box issues a commit does the message get deleted from the queue, or if the DataPower box encounters an error which is not handled by other means, then an automatic implied rollback occurs, like an MQ back, which means that it rolls the message back onto the queue as though nothing had happened. Now, if you do set the units of work on, you'll notice that a few extra fields pop into view underneath that field. Now, it's a little tricky when you do this in real life, because when you type a number 1 into that field and just leave the mouse cursor sitting there, nothing happens. You have to actually click the mouse cursor into the blank white space elsewhere on the screen for the JavaScript behind the web page to recognize the fact that you've keyed a value in, and then it pops into view the automatic backout radio buttons and the backout threshold and backout queue names. Now, if the automatic backout radio buttons are turned to off, then that effectively says we are not going to do any automatic backout, and we are not going to provide any backout threshold or backout queue name. This is a potentially dangerous situation, and I would certainly not recommend that. This would require you to be very scrupulous about your error handling inside the DataPower request or response rules. A better way to do it is to click the automatic backout button on, and that will cause the backout threshold and backout queue name fields to appear. You can then key in the names of the threshold value that you want to use for the backout and the name of the backout queue that's going to be used. Now, the threshold value is equivalent to the BO thresh parameter, which you would normally find on a local queue, to enable the comparison of the backout count in the message descriptor against the backout threshold parameter value. But if you put a value here, let's say 3 for example, this becomes like a fallback value or a default value that will be used if there is no backout threshold specified on the input queue. Similarly, the backout queue name is the name of a queue onto which the message will be placed if the backout count in the message descriptor exceeds the backout threshold. And again, the value you put here, the name you put here, is simply a default fallback value that will be used if there is no backout queue name defined on the input queue itself. Now we continue on. We have another tab in the Queue Manager Connection Object definition, which is the Connections tab. It begins with some parameters about the number of open connections, and then it talks about retry behavior and also conversation sharing. So let's look at them in turn. First of all, the total connection limit says how many connections can the Queue Manager Connection Object establish to the Queue Manager at any one time. Maximum number of connections. Default is 250, which is generally okay for most modern servers running MQ, but you can tune that according to your needs based upon the availability and processing power of the system where the Queue Manager is running. Similarly, initial connections simply says that when the DataPower system begins, when it starts up and establishes initial connections, it's going to try and establish the maximum number of connections that it possibly can according to the total connection limit, and it's going to build up a pool of connections that can be easily used by the various threads and the various instances of the various front-side handlers that are running connected to that particular Queue Manager. In other words, if you set it to 250, you could say the initial connections is 250, but that could flood the system. In other words, when you first start up, to suddenly hit the Queue Manager with 250 initial connections could overpower it and could cause problems. So you might want to limit this to a lower number. The default is 1, which means that as each connection is established and added to the pool, then another one will be established and added to the pool in a sequential linear fashion. Local address. You can specify what is the physical Ethernet interface on the front of the DataPower box that's going to accept the connections from the outside world into the front side handler that is going to process connections to this particular Queue Manager. Now, you are not limited only to a single port, by the way. Even though you specified an initial connection port up front, you can specify a range of ports by simply separating them with commas if that's appropriate to do so. Automatic retry. If the connection from the Queue Manager Connection Object to the Queue Manager itself is dropped in some fashion, you can check this radio button on which says I would like to automatically reconnect to that Queue Manager if the connection is dropped, or turn it off, which means that it's not going to automatically retry, which means that some human being has to come in and disable and re-enable the Queue Manager object in order to establish the connection again. If you do turn this option on, then you have the retry interval, which says how many seconds will I wait between attempts to reconnect to the queue manager. The default is 1 second, which quite frankly is too low. It should be between 10 and 15 seconds. If you're attempting to reconnect every 1 second, this could spike the CPU on the queue manager, or it could interfere with the processing capability of the DataPower box itself, and so it is not recommended to have it that low. 10 to 15 seconds is a good value. Then we get retry attempts, which says how many times should we attempt to reconnect at this interval, at the retry interval. Once that threshold is reached, there is another parameter called the long retry interval, which can be then used instead. So you might say, let's try every 10 seconds, say 20 times, and then after that we're going to go into say a 60-second retry interval for another 10 times or 20 times or 100 times or whatever it might be. Now if you set the retry attempts to 0, it's going to disable the long retry interval and just simply try over and over again forever at the short retry interval of 10 to 15 seconds. It is not recommended, however, that you do this. In other words, don't specify it as a 0 value. We recommend that you do set it to some non-zero value in order to make it actually retry appropriately. So here's the long retry interval parameter. As we said, you can set it to any value you want. The default recommended value is 600 seconds. Sorry, the default is 1800. The recommended value is 600 seconds, which is every 10 minutes. Whatever you set this to, it must be greater than the retry interval. If you have it any less, it's going to be ignored. Next we have the reporting interval, which says how often will DataPower log information about the retries, in other words on the system log, in seconds. Now it automatically suppresses duplicate log entries, so if you set this to a short amount, say every 1 second or every 10 seconds, it's not going to send a log entry every 1 second or every 10 seconds. It's automatically going to suppress any duplicates. It's only going to do it if some condition changes. Now another parameter is sharing conversations. This parameter has some interesting values. It can be set to a value of 0, 1 or some value greater than 1. And the way you set it affects the way DataPower interacts with the queue manager. If you set it to a value of 0, it means shared conversations are turned off, and what's more, any of the MQ version 7 or 8 features that are available, such as the administrator stop quiesce, heart beating, read ahead, client async consume, all of those features are turned off as well. You cannot use those advanced features. If you set it to 1, it also means no shared conversations, and however, it also allows those advanced features, such as administrator stop quiesce, heart beating, read ahead, and client asynchronous consume. They can now be used even though there's no shared conversations. If you set it to 2 or anything greater than 2, that means that we are not only allowing all those advanced features of MQ7 and above, but we also turn on shared conversations, and we also say how many shared conversations are we going to permit. Now, if you are not using these advanced features, the version 7 and above features, it can impact the performance of the front side handlers on the DataPower box. In other words, those advanced features can have an impact if you decide not to use them effectively. Continuing on with the Connections tab, if you scroll down further, there's a section on security. And this is where you can choose one of 2 different modes of operation when it comes to security. The first mode is the proxy profile mode, which was the old original methodology for connecting to the queue manager, and it's still supported for backward compatibility, but it is deprecated. We generally don't recommend that you use proxy profiles anymore because it had a lot of limitations to it. What we now recommend is that you choose the client profile mode, because with the client profile mode you then get to choose what is called an SSL client profile, which allows you to set up a whole lot of much more sophisticated parameters which are much more in keeping with modern technology, especially with version 7 and above of MQ in the queue manager. And by the way, if you're connecting to Xeos with version 7 or above, you must use the client profile method. You can't use the old proxy profile method. Notice if you do decide to use the SSL client type of proxy profile, then you have to supply a proxy profile and a key repository and other things like that. But with the client profile method, it's a little different. So let's look at the client profile type in a little more detail in just a moment and explain what that's all about. Now, if you choose the client profile, as we said, you've got to use that for ZEOS. If you choose the proxy profile, that's for backward compatibility. It then asks you for the key repository, whether you're using SSL version 3, and which physical single cipher specification you're going to be using. Notice it's only one cipher spec, and that's one of the limitations of the proxy profile method. But if you use the client profile, there's a separate object definition, which we're going to do a little tangent now and talk about the client profile object and then come back to the main QManager connection object in just a moment. So in the client profile main tab, you specify which protocols are supported, and notice by default SSL version 3 is not checked because, as you know, there are several shortcomings with SSL version 3, and so it is considered to not be a good solution, whereas TLS, being a more modern protocol and much more secure, is recommended. Notice also that we have a list of ciphers that you can specify here. You can choose a number of different ciphers that you want to use. Instead of being limited to a single cipher spec, which the old method used, you can now choose a whole bunch of them. You simply choose them from the pick list below and then click the add button to add them to the table above. You can also use the SNI parameter as well. And then you can also specify various identification and validation credentials down below. So, as we said, you can nominate which protocols are supported. You can choose which ciphers are going to be used. You can also specify whether you want to have server name indication TLS extension in the client hello message, and if you choose that to be yes, then you can specify the custom SNI host name to be used. You can also choose SSL compression, but it is not recommended because there are a couple of attacks now which are being developed by the bad guys called the crime attack and the breach attack, which make use of SSL compression shortcomings in order to discover what the keys and certificates are in order to break through them. Identification credentials, if you're using mutual authentication, then you may need to supply those credentials from the client back to the server. Validation server certificate, whatever certificate is presented to you by the host is checked against the validation server certificate, and you can then specify also the validation credential object that's going to be used for that validation purpose. Continuing on with the client profile, there's a session caching tab that gives you the ability to specify some caching information. You can decide whether you want to allow SSL session caching at all in the first place, and then a timeout. How long before the cache is flushed? The maximum is 24 hours. It depends upon how often your keys and certificates change, because the bigger this is, obviously the quicker it's going to be for validating the cached information, but the bigger it is, the possibility exists that the cache may end up being out of date. Then the session cache size, how many entries can be cached? Maximum is 500,000, bearing in mind that this will use up available memory and may not necessarily be a good idea. Continuing on, there's an advanced tab at the very end of the client profile setup, and this is where you can specify elliptical curve algorithms to be used instead of the standard algorithms. Now, this is part of RFC 4492. These are somewhat similar to RSA, but they allow you to use a smaller key size but give high security. Mobile technology systems prefer to use elliptical curves because of the lack of available resources on mobile systems in terms of CPU processing capability, memory availability, and also the lack of crypto hardware. So it's a good idea to invoke the elliptical curves if you know you're going to be dealing with messages coming from a mobile technology system. Now we go back to the QManager connection object as promised. We have a CCSI tab, Coded Character Set ID tab. This is normally set as a default to 819, which is the Linux ASCII code set, and that's usually how you should leave it. Convert input, this allows you to specify whether you want the DataPower front-side handler to handshake with the server connection channel agent and decide whether or not we're going to convert the message formats using the CCSI. Usually leave that on as a default, and that way conversion will take place automatically, especially valuable if the host system is a different physical code set, such as EBSADEC on a mainframe and so on. Then we get the MQCSP tab. As promised earlier, this is the area where you can specify a little more security as far as connection is concerned. Gives you the ability to simulate the passing of an MQCSP as though you were using an MQ-CONX to the queue manager in the first place. If you specify the user ID field, it will set up and send an MQCSP object for you at connection time. If you leave this field blank and also the password alias is set to none, no MQCSP is sent, and the MQ frontside handler behaves like a standard, ordinary MQ client pre-version 7 and just simply sends the embedded user ID, which, as you know, is not a very good security thing. But if you do decide to use the user ID in the CSP, then you also supply a password alias, because what happens is the passwords stored within DataPower are encrypted for security purposes within DataPower, but they're extracted via the password alias and then sent in clear text in the MQCSP connection object, which means you should be using SSL or TLS if you decide to use the CSP methodology. So that's as much as we can say about the MQ Queue Manager connection object within DataPower. Now we dive into a multi-protocol gateway and we decide we're going to set up a front-side handler object to actually establish the connection, open a queue for input, and start reading messages from that queue. The first screenshot is the main tab, and we'll explain what each of these fields mean in more detail as we go forward. The get queue. This is the name of the MQ queue from which the front-side handler will retrieve its messages. It follows the standard MQ naming convention, A through Z, 0 through 9, period, /_%, upper and lower case, and it must conform exactly to the actual queue name being offered by the queue manager. Case sensitivity is important here. Now, this field must be entered unless you're using publish and subscribe, which I'll talk about in more detail later. The put queue is optional because there are several different reasons why. Firstly, you might be using what's called one-way messaging. In other words, fire and forget. In other words, you are getting a message from a queue using the get queue, passing it through a request rule, throwing it out the back end to some back end server, and that's it, you forget all about it. There's no expectation of a reply, there is no response coming back from the back end server to be handled, so there's no need for a reply queue. That's one reason why you might not need a put queue. Another reason is that you may be using the reply to queue name embedded in the message descriptor of the message coming back, in which case you simply extract that reply to queue name and use that dynamically to choose where to send the message back. Or you might be dynamically, programmatically coding the reply queue name in the actual response rule code itself, making your own choice as to where that message goes back to. And there's a fourth reason which isn't mentioned here, and that is if you're using publish and subscribe, you might leave this blank because you're putting in a publish topic string instead, which I'll talk about in a little more detail later. Next we get a field which is the number of concurrent MQ conversations. This says how many parallel active and pending MQ gets are we going to have on the get queue. In other words, what happens is that the MQ frontside handler will automatically replicate itself into multiple instances, and each instance will establish a connection to the queue and open the queue for input and do an MQ get, all in parallel with each other, in order to try and improve throughput, as you can probably appreciate. Now, the recommended value of this is 1. In other words, you should only have one instance of the frontside handler running at a time. Now, under normal circumstances, that's plenty. That works just fine. But if you have a high throughput situation where the messages are piling into that queue at a very fast rate and you want to be able to pull them off as quickly as you can and process them through in parallel, then you could use up to 5, but any more than 5 you're going to find that the contention between the front-side handler instances and the contention on the queue manager is going to become counterproductive. Again, it's one of these cases of try it and see, set it to different values, do some performance testing, monitor the throughput, get some accurate figures, and then try a different value and run it all through again. But regardless of this setting, within a single front-side handler, it is still possible for the front-side handler to multi-thread itself. So all we're doing with this is simply explicitly saying how many instances of the front-side handler will be running, but even a single instance front-side handler could multi-thread itself. But as a multi-threaded front-side handler, it obeys the concept of message sequencing, whereas if it's multi-instance, then each instance is running independent of each other. So this is the important thing to note, especially if you're using the logical order concept. In other words, if you have message grouping, you should never have this value set to greater than 1, because this will destroy the concept of logical order. So that's an important consideration. If you know you've got message grouping, do not set the concurrent MQ conversations to anything greater than 1. Next, we get message options. This is a field in the front-side handler itself which contains a numerical value consisting of the arithmetic addition of the get message options parameters. This can override any specific parameters set elsewhere, including in the MQ-QManager connection object itself. This means that you can also include get message options that could override the syncpoint processing value. In other words, even though the front-side handler is normally obeying the parameter that's set in the QManager connection object that says units of work 0 or 1, if you set units of work to 1, which means that it will turn on syncpoint, you can override that for this particular front-side handler by setting that particular get message options value to include a numerical value that turns off syncpoint for this particular front-side handler. So this is how you can override that capability. Next is polling interval. This is equivalent to the wait interval that would be used in conventional MQ programming. It simply says that the front-side handler will issue a get with wait, and it will wait for this number of seconds to see if any messages are arriving on that queue. After that particular wait interval has expired and there are no messages, the front-side handler will then go back and immediately issue another get with wait for that same time period. If you set this value too low, it means that if the queue is empty, the front-side handler is going to be continually interrupting the queue manager very often to issue another MQ get, which could be, again, counterproductive. We recommend a value of 30 seconds. That's a nice round number that seems to work very well. Anything less than that, you could be impacting the queue manager unnecessarily. Retrieve backout settings. Remember, back on the queue manager connection object, we specified the backout threshold and backout queue names. Those were the default values. In the individual front-side handler, you can set this parameter on and you can say, I would like to retrieve the BO thresh and BO queue names from the queue itself, from the individual queue that we're getting from. And this is only relevant to this one input queue. In other words, any other front-side handlers that don't have retrieve backout settings will not be affected by this. It only affects this one instance of the front-side handler. Now, here's the important point to note. If you do set this on, it is very inefficient, because what it does is it issues an MQ-INC call before every MQ get, which, as you can imagine, is a performance hit. It will impact the performance. It will slow down the throughput of getting messages from that queue. Accordingly, it is highly recommended that what you do is turn this off and make use of the queue manager object settings. The downside of that, of course, is that every front-side handler then will be using the same backout threshold and the same backout queue name. So you may have to program your way around that in terms of handling the bad messages that are put onto the backout queue, because they'll be coming from multiple different front-side handlers. So somebody has to sort out which one they came from when they are processing them later. By the way, Just for reference, this is a list of some of the MQGMO options that you can arithmetically add together, and notice that you can turn off syncpoint by including the number 4 somewhere in that arithmetic addition, and that will cause syncpoint to be turned off for this front-side handler only. Continuing on, use the queue manager in the URL. There is a field available to you, a service variable called var://service/url-in, and if you are dealing with MQ queue manager groups, what can happen is that if the front-side handler loses a connection to the queue manager, it's going to go to the group list and it's going to choose another queue manager from the group list and attempt to connect to it instead. And when that happens, you may say, well, I'd like to know which physical queue manager did I end up connecting to. So if you turn this option on, then it's going to put the name of the actual chosen queue manager into this variable. But if you turn it off, it's just going to simply show you the name of the queue manager group object and not give you any differentiation between which queue manager you're connected to. So that's the purpose of this particular field. Its default is off, which in my opinion is a bit useless. I prefer to turn it on in case I need to know what actual queue manager I'm dealing with. And this is particularly useful if I'm constructing my own log messages to give information about errors that are occurring during the processing of messages. So I prefer to turn it on, and that way I can capture that information out of that variable and include it in log messages. Next parameter is CCSI. Now remember that the queue manager connection object itself has a CCSID value, which indicates the global CCSI for the DataPower box itself, but for each individual front-side handler you can override that. This could be useful if you know you're dealing with a queue manager that is a transitory queue manager, meaning that it's only an intermediary between DataPower and the final destination. So you can set this to any value you want in order to construct a message in some other format and send it through the current queue manager to some other destination queue manager. You can also include other values to simulate the MQCSI embedded or MQCSI inherit values, as you can see shown here. Continuing on, if we scroll down the front-side handler main page, we have extra fields, and we're going to talk about what these mean next. Firstly, publish and subscribe. If you include a subscribe topic string in that field, this will be used to subscribe to the incoming topic as the input to this front-side handler, rather than using a specific get queue for point-to-point retrieval. If you also specify a get queue, it will take precedence. In other words, you have to leave the get queue field blank if you include a pub sub topic string. Now it's important to note that this is a pub sub topic string. This is not a queue manager topic object name. So in other words, you have to have the full topic string here, not the actual topic name, which is a bit of a pain because it means you can't use topic objects and all the necessary security that goes on with them and so on. Subscription name. You can establish a durable subscription from the MQ frontside handler within DataPower if you want to, by putting in a durable subscription name here. That will either create a durable subscription up front initially or return to an existing durable subscription later if you dropped your connection and came back later. If you leave that blank, it assumes a non-durable subscription which is cancelled as soon as the DataPower system drops its connection or the frontside handler object is disabled. Publish topic string, similar to the subscribe topic string, allows you to send the response back to the queue manager as a topic rather than a point-to-point queue. If the put queue field is non-blank, then this field is ignored. It takes precedence. Parse properties. This option allows you to extract the properties from the message header, that is the RFH2 header, and put them into a node set that can be then interrogated later in your request rule if you so desire. In other words, it makes the properties available to you as name value pairs that are easily retrievable and easily used without the necessity of traversing through the header to find them. There is a minor overhead in parsing, especially if you have a lot of properties, so it's advised to leave it off unless you need it. I've found in my own testing that it's not all that relevant in terms of overhead, because most people don't use too many properties, and so I usually turn it on because I like to play around with properties most of the time. The next option is selectors. This allows you to do selective retrieval of messages from a queue based upon certain property values. It's a SQL92 format. It was introduced into MQ to support JMS and then became available for other languages as well. In my opinion, you should never use selectors under any circumstances, whether you're writing JMS or traditional MQ applications in other languages or in a front-side handler within DataPower. Reason is it forces a sequential search through the queue, so it is very inefficient, especially if you have a queue with a large number of messages, say 10,000 messages or something like that, and you say I want to only retrieve messages where the property of color equals blue. It's going to go searching sequentially through every message in the queue until it finds the one that says color equals blue. And then having gotten that and processed it, when it comes back to get the next message, it's going to start from the beginning of the queue again and search through looking for color equals blue. In other words, it goes back to the start of the queue every time and starts searching through from the beginning. It does this because it has no way of knowing whether any new messages have been added to the queue in the meantime. So it always starts at the beginning and continues through from that point on. So in my opinion, it's a very bad thing. I always recommend to people, do not ever use selectors. Find some other way programmatically to work it out. Next, exclude message headers. This is a bit of a misnomer. This exclude message headers option seems as though it's going to essentially or delete those message headers, but in reality what it's doing is it's stripping those message headers out of the MQ message and parsing it into a usable form. So it's really badly worded. What they should have said was extract and parse message headers. That would have been a better word for it, because it makes those headers available for you programmatically inside the request and response rules. So try to remember that when you see this, that it doesn't actually mean get rid of them, it simply means make them available. So the wording's strange. Next we say, what about the content type? Because in order to work out whether we are dealing with a SOAP message or raw XML or binary or JSON, we need to know what content type are we playing with. And we can dynamically extract that from the message descriptor, the old original RFH header or the RFH2 header. Having chosen which one we want, we then include an XPath expression that will navigate through this header to find a field that represents the content type that we can then use to parse the body of the message into its correct format. Async put. This is an option that lets you put a message to a queue without waiting for a response. It will not work properly if you have units of work set to 1. It is not recommended that you use this method because essentially what it's doing is it's the front-side handler response section pretending that it actually did successfully put the message to the queue, whereas in reality it's actually buffering it in its own memory and then issuing a command back to the actual multi-protocol gateway to say, yep, your message got put, we can now continue. And then in background and in parallel, it puts the message physically onto the queue separately. But if something goes wrong at that point, then you're in trouble. Now, in traditional MQ programming, it can be useful. In my opinion, it is pretty pointless with DataPower. I generally recommend that people don't use this technique. Next we have batch size, which says if we do have the units of work set to 1, which means we have syncpoint turned on, how many messages are we going to read from the queue under a single syncpoint before we do a commit or a rollback operation? We recommend you leave that as 0, which means that every message is a separate transaction. You could set it to 1 if you wanted to, which has the same effect, but please don't set it to anything greater than 1. That will cause a lot of problems. It's not recommended. It's a lot quicker and more efficient to just simply leave it at 0. So that puts to bed the front-side handler. Now we turn to the back-end URL of the multi-protocol gateway and how we define our interface to the queue manager on the back end. There is a syntax that we use in that URL. dpmq:// is the protocol prefix. Obviously, It's a made-up protocol prefix. It doesn't exist in the real world like HTTP does or FTP, etc. DPMQ is DataPower MQ integration only. After the : / you then have the name of the queue manager connection object that you previously defined, then a slash, and any URI that you want to propagate to the queue manager, which is quite frankly fairly pointless because MQ itself doesn't really make use of URIs, but you can if you want to. Then we have a question mark, and then we have the various query strings that represent various parameters that are passed to the queue manager. And these query strings are simply name equals value, semicolon, name equals value, semicolon, strung together one after another in traditional URL syntax. So looking at these parameters in turn, request queue, request queue, all one word, equals the name of the request queue that the message will be put onto on the back end. This is mandatory. You must have this present. Reply queue equals what is the name of the reply queue from which the back end will retrieve the response message coming back from the queue manager. This is optional because it might be a one-way message, or we might be using the reply to queue name dynamically to choose the back end reply queue name. Sync equals true. This has a special value and a special significance, which I'm going to cover in much more detail later. But suffice it to say, if you have this option included, sync equals true, at the point where you put the message onto the request queue, a commit will be issued at that same point, and that will cause that message to be immediately committed onto that back-end queue. If you leave that parameter off, or you set it to sync equals false, then it will simply put the message onto that queue and not do a commit. And this has ramifications under certain circumstances, which I'll talk about in more detail later. GMO equals, this is where you can arithmetically add together the GMO options values to control how the message is retrieved from the reply queue. And PMO equals lets you do a similar thing when you put the message onto the request queue. Both of these can be used to override the queue manager connection object parameter values that you've got set. Parse headers equals true or false says whether or not we're going to parse out the headers that are coming back from the reply queue and make those variables available to us. That's the exclude headers parameter I talked about earlier on the front side handler. It makes the headers available for you programmatically. Set reply to, true or false, says are we going to use the message descriptor reply to queue name during the put to the response queue to set the name of the reply queue that we're going to be retrieving from when the message comes back. Async put, again, true or false, we can turn on the async put option on the back end request queue. Once again, I strongly recommend you don't do that. And then lastly, you can do browsing on the reply queue. You can selectively retrieve from that queue non-destructively if you choose to do so. This can lead to all kinds of programmatic nightmares, as you can imagine, because DataPower is not really set up to handle browsing all that well. It's only really included in order to provide full compatibility. I strongly recommend that you never use this particular option. Continuing on, content type header. Which header is going to contain the content type so that the response rule can parse the contents correctly? And once again, the XPath expression of where to find that information. Parse properties, similar to the front side handler. Parse out the message properties into a node set that we can extract from and use programmatically. Publish topic string, instead of including the response queue name, we can instead publish that information with a publish topic string. And similarly with the reply queue, we can subscribe to the response instead of reading it from a point-to-point queue instead. Once again, subscription name, allowing us to set up a durable subscription for the reply if we want to. And then finally selectors, which is the same as on the front side handler, to selectively retrieve messages from the reply queue if you so desire. Again, I strongly recommend please don't do that. It gives you a performance hit. So that's pretty much it as far as the back-end URL is concerned. Now, within the multi-protocol gateway itself, there are certain parameters that can be set that can control the way in which MQ is accessed and interfaced with. In particular, the headers tab is one area where you can have some control over what's going on. And in particular, what you can do is you can inject headers into an MQ message, and you can either inject them going in from the front side handler, or you can inject them coming back from the back end. And you choose front or back depending upon whether it's the front side or the back end that you're dealing with. You then choose the header name, and it's MQMD or MQRFH2 or whatever it might be. Then the header value has to be a full XML expansion of the header, but notice that within that you only need to specify the fields you want to change. In other words, it will assume all the default values that MQ normally expects of those headers, but only lets you change certain fields within that particular header. So it injects individual fields. So notice the example at the bottom of the screen. We are injecting into the message descriptor a format field of MQSTR and a persistence value of 1, so we're setting this message to be persistent. So we're dynamically affecting the way that message descriptor is constructed by injecting a particular header. Now, a few more things. Programmatic control. If you decide you want to use a style sheet to handle MQ, you can manipulate those headers in a similar fashion to the Inject Headers tab, but with a lot more programmatic control, with if then else's and looping constructs and all kinds of things like that. So this is a snippet of a style sheet showing a template which is constructing a variable called new MQMDSTR, consisting of, again, the full XML layout of that particular structure, setting the format to MQSTR and the persistence code to 1. Having done that, we then serialize that particular string variable into a separate variable which is called MQMDSTR by itself, and then we can simply print out that information if we wanted to, and as shown here we're creating a log entry showing the contents of it. But then what we can do is we can set a request header using a DataPower extension called setRequestHeader, appropriately enough. We say the name is MQMD and the value is going to be the contents of that serialized variable. In a similar fashion, we could also set the response header, which has been commented out for the sake of this particular illustration, but we could do the same thing there. So whichever we want to set the request header or the response header accordingly. So you have the ability, as you can see, to programmatically control all the different variables that you may want to use within this. Now, continuing on down this screenshot, you'll notice down towards the bottom it says dp:/URL open. This is an extension, DataPower extension, that lets you explicitly open a particular queue manager and connect to it using target equals, in this case dpmq://dp4:?, and then all the parameters that we specified in the back end URL. So in this case we are programmatically and dynamically manager inside a style sheet in the middle of a rule, probably inside of a transform action, without involving the front side handler or the back end URL at all. So it is an in-flight access to a queue manager, which can be very handy to maybe send a message off to an audit queue or something like that, or retrieve an extra message from some other queue that we want to make use of, and so on. So you've got full MQ programmatic control at this point. Now what's worth mentioning here too is that if you decide you want to access a queue manager directly without the burden of setting up a queue manager connection object, you can actually say the URL is MQ:// without the DP in front of it. Then what you have after that is the host name or IP address, :port, then you have a slash and then question mark, and then you include the server connection channel name and all the other parameters necessary to do a dynamic connection to a queue manager without the necessity of setting up a queue manager connection object at all. So in other words, you're programmatically connecting to any queue manager of your choosing inside of a style sheet, which can be very handy as well. Now, There's also a way of using context variables to inject into the message descriptor header. In order to do this, you have to, in this example at least, set the transform actions output context to events, and then set the result actions input context to events. So here, now what we do is we say XSL variable called MQMD string is equal to, and then we set up our message descriptor with all of the parameter values we want. Then we do the serialization of that information into MQMD str2. Then what we do is we use the set variable option within DataPower to set the context / events / underscore extension / header / MQMD, and that causes the events context variable to now contain a message descriptor properly constructed with all of the MQ parameters embedded in it. You can also work with JMS headers programmatically. This screenshot is taken from a trace, so you can actually see what's going on. And in this case, we are showing the message descriptor fully parsed out into XML format, which means that you can access and manipulate any of those you want using style sheets or using JavaScript. And notice that the message properties show up as a separate header called an MQMP, which has property name equals, and then it has the type, and then it has the actual value, and so on, all strung out one after another. And if you're working with JMS, for example, you're going to see that there's a folder embedded in there called jms.tms and jms.dlv, which are the various JMS parameters that you can make use of and manipulate according to your needs. This allows you to work with the message properties so long as you have turned on the option on the front side handler saying parse properties, and so long as you've not set exclude RFH2. In other words, that must be turned off. Conversely, you can work with the RFH2. In this case, you turn off the parse properties and turn on exclude RFH2, and now what happens is the RFH2 appears with all of the parameters embedded in it spelled out for you as separate folders, but notice it also extracts for you the individual folders and shows them to you as separate data structures. The second one with the grey background is all of the JMS folders separately split out for you, so you can easily get to them and manipulate them using either JavaScript or using XSL inside of a transform action. So my preference is normally to go this route and use the RFH2 method, because you get much more programmatic control over everything that's present. Error handling. The reason code that comes back from MQ is exposed as a DataPower variable called x-dp-response-code. So you can extract that reason code, and you can then make use of that in order to use it for logging or making some decision inside of the logic of your style sheet and so on. So it gives you, again, full programmatic control over handling that particular error code that comes back from MQ. And continuing on, something else that needs to be mentioned is conversational processing. The philosophy of the back-end handler within DataPower is that it assumes that whichever application it's sending the messages to is conforming to the conventional methodology of handling message ID and correlation ID. That is to say, it expects that the back-end application will copy the message ID from the incoming message that was put onto the request queue into the correlation ID of the message that gets put onto the reply queue, because the back-end handler within DataPower uses the correlation ID to retrieve the message coming back. That's how it knows which particular message is to be handled by this particular response rule in the same multi-protocol gateway, in the same policy that is part of that particular message flow, that particular conversation. Another thing that's worth mentioning is that you can simulate MQ-Put1 with DataPower by setting the MQ object descriptor header with the queue manager name in it. Unfortunately, DataPower does not have any concept of issuing a true MQ-Put1. So what it's doing is it's issuing an MQ open, MQ put, MQ close every time. This obviously is inefficient and is not the recommended way of doing it. So if possible, try not to use dynamic queue manager or queue names where you can help it. Reply to queue. If you set this parameter on to say reply to queue usage, then that means that the response rule will send the message to whichever reply to queue name you specify or is currently in the message descriptor. And the same is true with the reply to queue manager. You can set that to a different queue manager if you want to, so that the response rule will send it there. If you're dealing with a cluster, you don't need to set the reply to queue manager. It will automatically send it to whichever queue manager you're connected to, and that in turn will distribute it to the destination. So here's a little snippet showing how you can set the reply to queue name and reply to queue manager name in a request rule. The important things to note are the variables, the context variables called myMQMD/reply to queue and myMQMD/reply to queue manager. Now the myMQMD is a context that has been set up within the actual rule itself, and that has to then be propagated through the actions in order to make this work correctly. But once that's been set correctly, that particular value will be obeyed and used for all MQ access from this point on. Continuing on, we're now showing you how to set the reply queue and reply to queue manager in a response rule. In this case, having set those values, we now serialize that customized MQOD structure that contains those values inside of the object descriptor, and that then becomes part of the object descriptor, which is used to establish the connection to the particular queue that you want to send that information to. So in other words, it is dynamically reopening that particular queue. As I said earlier, it's doing a MQ open, MQ put, MQ close rather than an MQ put one. Now we get to the interesting part. Now we're going to be talking about transactional processing, because it's important to understand the ramifications of using the units of work parameter along with the sync point parameters that are available to you on the back end and on the front end as well. The first and most important point to note is that MQ and DataPower are connected using standard client connections. That is to say, the DataPower box does not have a queue manager. It does not have any queues. It does not have standard send and receive channels. It can only connect as a standard client. It is not the extended transactional client, which means you cannot do two-phase commit. It does not support XA switching methodology. So those are some important considerations to make note of. DataPower is considered to be an application by MQ, therefore there is no inherent message integrity. Just like any normal MQ application, once the application has the message, it is the responsibility of that application to protect the integrity of that message. MQ has no further part to play in that message. Now, there's some interesting phenomena that can occur if you have the same queue manager on the front side and on the back end. So in other words, if DataPower is only connecting to one queue manager at the front and the back, then you can achieve true message integrity, because you can establish a unit of work on the front end and hold that unit of work open until the back end has completed its work and put the message onto a reply queue on the back end, and then do a commit, thereby ensuring that the message is only deleted from the front end queue once it's successfully stored on the back end queue. This also ensures once and once only delivery, because it's a single unit of work. Conversely, if you have a different queue manager on the front and the back, two different queue managers, they are completely separate. There is no concept of two-phase commit between them. Message integrity is only assured if the DataPower system is configured properly and programmed properly. And what's more, there is a possibility of messages being sent more than once if the programming construct is not well thought out on the DataPower system. Let's talk this through with some diagrams. Let's start off with the simplest scenario. Two different queue managers, one on the front, one on the back. No transactional control. Units of work set to 0 on the front side handler. Sync equals false and transactional equals false on the back end. So application 1 in the top left corner puts a message onto fs.in, frontside.in queue. The frontside handler on DataPower gets the message and passes it through the request rule. By the way, the action of getting that message from fs.in deletes it from the queue immediately, and there's no rollback capability. It's gone forever. It goes through the request rule and gets put onto be.out, backend.out queue. At that point, the message is immediately visible. There's no commit, no rollback. It is completely and irrevocably put onto that queue. Application 2 can pick it up and process it, put the response on be.in, backend.input, and from there the response rule gets the message, and there's no sync point, no transactional. It gets it immediately, gets deleted from the queue. It's now the responsibility of DataPower to handle it all the way through the response rule and put it back onto fs.out, which is again immediate and irrevocable, instantaneous availability. Application 1 picks it up and can process it. Fairly simple stuff, but it requires DataPower to be well programmed to handle any error conditions intelligently, otherwise messages may get lost or doubled up. So the total responsibility then is inside DataPower. Now what happens if we turn on syncpoint on the frontside handler only? In other words, we have units of work equals 1 on the queue manager connection object. So in this case what happens is that the action of getting the message from fs.in by the frontside handler will start a new unit of work. So now we have syncpoint on. We have that message pending delete on fs.in, but not yet deleted. The message goes all the way through to the back end, and the back end puts the message onto be.out. In this case, there's no syncpoint processing on the back end, which means that as soon as be.out gets that message, it signals back to the back end, completion code 0, reason code 0, everything was successful, your message has now been stored here. As soon as the back end gets a completion code 0, it signals the frontside handler to say, success. This request rule has now come to a successful completion, and so the frontside handler issues an MQ commit, thereby causing the message on fs.in to be deleted. So in this respect, it could be said that message integrity has been preserved because the request rule will only do a commit once the message has been successfully stored on the output queue. Then application 2 picks up the message from be.out, puts it onto be.in, and the response rule gets the message from that queue immediately, no sync point, deleted straight away from be.in, passed all the way back to the frontside handler, which puts it onto fs.out. And in this particular situation, even though units of work is equal to 1, the fact that it puts it onto fs.out will simply do a commit straight away anyway because it was successful, and there is no rollback capability to either of those queues from this point on. Now, what about if we turn on transactional control on the back end, but not on the front end? So in this case, application 1 puts the message on fs.in. The frontside handler on the request rule picks it up and reads it immediately. Immediate destruction. The message is gone completely from fs.in. No rollback, no recovery capability. Goes to the back end, gets put onto be.out. Sync equals false in this case, which means that there is no commit done on the back end, nor does there need to be, because it's the first message being put onto this back end queue, and there's no transaction outstanding, and so the message just simply gets put and is immediately available. There's no sync point involved whatsoever. Application 2 can pick it up and process it, puts it back onto be.in, and then the back end reads that message from be.in under sync point control, because transactional equals true in this particular case. So that phrase is present in the URL. So now a new unit of work is started on be.in. The response rule runs to completion, does an MQ put to put the message onto fs.out at the frontside handler. The frontside handler, upon getting a completion code of 0 back from queue manager QM1, sends a signal to the back end to say I've been successful, and so the back end now issues the MQ commit onto queue manager 2, thereby deleting the message from be.in. But if any error had occurred throughout that response rule, then an automatic rollback would have occurred. Now, what if we turn on units of work on the front side handler, and we have units of work turned on, transactional equals true turned on the QM2 queue manager but not sync. So in this case, the request rule will get the message from fs.in under syncpoint, holding a unit of work open until such time as it gets to the end of the request rule and puts the message successfully onto be.out. This will again cause the message to be stored on be.out. This will cause the queue manager QM2 to signal a successful end of transaction, in other words a completion code of 0, and that will cause the front side handler to commit the message on fs.in, end of that transaction. App2 picks it up, puts it onto be.in, and then the response rule, just as before, creates a new unit of work to begin the transaction, getting the message from be.in, and that will hold true until the response rule gets all the way back to the front side handler. When it puts the message onto fs.out, gets a completion code of 0, it signals the back end to do a commit, and that means the message is then deleted from be.in. So here we have a certain amount of transactional integrity in the sense that both the request rule and the response rule could, under error conditions, roll back to their respective queues in order to try again and protect the integrity of that message. Now, what happens if we have a single queue manager? And this is a scenario which is used quite a lot. I've come across this quite a lot in the field, where people have a single queue manager and they're employing a DataPower box to do certain functional control of things like encryption and decryption and threat protection and things like that. And so they're taking an application 1, putting a message onto fs.in in order for DataPower to do something to that message, something complex, transformation or whatever it might be, and then put the message onto another queue, so another transaction, another application running on the same queue manager can now handle that transformed message quickly and easily, and then send a response back, perhaps to the original application. So in this case, no transactional control, same queue manager, fs.in gets an MQ get from the front side handler. In this case, units of work 0, immediate deletion from that queue. The message is now under the control of DataPower, no rollback capability, no commit capability. If DataPower loses the message, tough luck. MQ has no further part to play in that. MQ doesn't know or care what happens to that message from this point on. Gets put onto be.out, immediately available, no transactional control. App2 picks it up, processes it, puts it onto be.in. The back end picks up the response from be.in, immediately deleted from be.in, no rollback capability, gets handed all the way back to the front side handler and put back onto fs.out, immediately available, no commit necessary. So that's the simplest way of doing this, and it requires that DataPower have absolute control over the message, and it controls the fate of the message, it controls the integrity of the message. Now, what happens if we turn on front side transactional control only? In other words, units of work equals 1, and on the back end we have sync equals false, transactional equals false. Here's what happens. Application 1 puts the message on fs.in. The front side handler for the request rule picks it up and starts a new transaction. That means the message is held on that input queue pending delete, a new unit of work is begun, and it holds that unit of work open until it gets a commit or a rollback. The message gets passed through the request rule, gets to the back end successfully, gets put onto be.out. However, remember that the queue manager, QM1, sees the DataPower box as a single entity, as a single application. Therefore, it considers the same unit of work to still be open and still be outstanding. So the fact that the back end has put the message onto be.out is immaterial at this point. Nothing can happen to that message until a commit is done. And a commit will not be done because the request rule is waiting for a successful completion of the back end handler to do the commit. And it won't get that because it is still an outstanding transaction. So essentially, you end up with everything hung at this point. Application 2 can't see the message, cannot retrieve it, cannot process it. The backend be.out.queue is just going to sit there waiting. The queue manager is going to sit there waiting. DataPower is going to sit there waiting. Everything is hung at this point. So not a good situation. So be very careful if you are dealing with a single queue manager and a single DataPower box connected both front and back to the same queue manager. Be sure that you have the back-end transactional control set correctly. And this is how you do it. You set sync equals true. You may remember when I introduced this parameter, I said what it does is it issues a commit on the back end. And you might be thinking to yourself at the time, why? Here's the reason why. If you have a single queue manager, and we go through the same scenario as before, the front-side handler getting the message from fs.in will start a new unit of work, and when the request rule back end puts the message onto be.out, because sync equals true, it's going to issue a commit at that point. And that's going to commit that entire unit of work, that entire transaction. It will now delete it from fs.in, make the message available on be.out, and that's the end of that transaction. So this is protecting the message integrity completely all the way through the request rule. Because if the request rule gets an error, it'll roll back to fs.in. If the request rule successfully completes, the sync equals true will issue a commit, and that will then complete that transaction successfully. Now app2 can read it, put it onto be.in. We can then read it from that and run it all the way back to fs.out. This time the request rule is operating outside of sync point control because transactional equals false on the back end. Conversely, if we turn transactional equals true on, that means that not only is the request rule operating under a unit of work, but also the response rule, because in this case the back end retrieving the message from be.in will start a new unit of work because transactional equals true. That will go all the way through to the front side handler, put it onto the fs.out queue, and at that point it will issue the commit, and that will delete it from be.in and make it available on fs.out from this particular point of view. Now there is a particular phenomenon in MQ which I'm sure you're aware of called a poison message. This is where the front side handler could read a message under sync point from the fs.in queue, encounter an error halfway through the request rule, and the normal default mode of operation is to do a rollback. In other words, it puts it back on the input queue as though nothing had happened. Then, of course, the front side handler will do another MQ-GET and get the same message again, encounter the same error and roll it back, and get it again and roll it back and get it again and roll it back, over and over again. And if nothing were done to sort that out, it would just keep doing that over and over again, and you would end up with a poison message loop. So what you do is you set a backout threshold, in this case 3, and a backout queue name, in this case fs.er, so that when the threshold is exceeded, when the backout count on the incoming message is 4, the request rule encountering an error will cause the placement of that message onto fs.error, and a commit will be issued at that point, and that will then delete the message from fs.in, so the very next MQ-GET from fs.in will get the next message on the queue, and the poison message is now being diverted to another queue for processing. Now, what happens then if we don't have a backout threshold set? Let's say we left the backout threshold and backout queue names blank on the queue manager connection object, and if we left the if we tried to retrieve the backout threshold and backout queue from the local queue, only to find there wasn't one there. In this scenario, you will get a true poison message loop indefinitely, which is interesting because if you look at the documentation for DataPower, it says explicitly if there are no backout settings, the backout function is disabled. Well, I'm here to tell you that's not true. And I've actually lodged a request with IBM to change the documentation because it's actually incorrect, and I've actually tried this out myself. I set it up on my DataPower system and set it running, and it just sat there looping and looping and looping, and I let it run for about 2 days, and the backout count got up to about 6 million, and then I decided to stop it because I couldn't be bothered waiting for it. But the point is, during that time, essentially my system was useless. I couldn't process any more messages through my DataPower box because it was simply looping on that one queue. So be very careful of the way you set these backout settings. It can have an impact, obviously, on the integrity of your system. So normally I would ask for questions and answers if this were a live presentation, but I'm just simply going to thank you for watching this, and just to give you a sense that this was a taste of some of the functionality and capability of DataPower integration. What I didn't get into is the JavaScript notation technique that you can use in the script object, the script action rather. The gateway script action is the full title of it. That's something I can teach separately. I can also teach all of the other ins and outs of MQ application development within DataPower and MQ application development outside of DataPower. I can also teach DataPower administration and development and so on. And if you want to get a copy of these slides, I've got them on my website, robinwileytraining.com, under a directory called MQTC2016, all uppercase, because I did this presentation at the MQ Technical Conference in September 2016. And I highly recommend that you search that out online and attend one of these conferences, because there's a lot of valuable information to be gained from attending this conference and learning a lot about how MQ operates. So that's basically it as far as this presentation is concerned. I look forward to dealing with you in person someday and teaching you more about DataPower and MQ. Thank you for your attention, and see you later.